Hi, this is the video for homework 3, question 1. So first, let's read this question together. So first, a large store in an electrician's workshop has 50 meter of... Okay, first of all, for this kind of questions, there's no figure, right? So since it has no figure, this chapter is about the circuit, we can know that we probably wouldn't use the formula. We probably wouldn't use this kind of formula, right? Because there's no figures. There's no way we can analyze the circuit. So in order to solve the questions in homework or exam as quick as possible, we need to accurately locate the formula that we're going to use. So for this kind of question, we can have a sense that it probably required us to use formula like this two, or we probably need to make some comparison in order to have got the answer. So first, now we know that we're gonna use the formula, this formula, right? So when we read through the questions, we better looking for the informations that we can substitute into these equations. So first, we have a 50 meter of isolated 1. Okay, now we know that we have a wire, right? And it has 50 meters long, so we can write down the length is 50 meters. And then when the electrician connects a battery to the ends of the wire, the resulting current is 1.2 A. So we know current 1 equals 1.2 A. And some weeks later, after cutting off the length, so we know we have this is L1, and we have length 2 equals, it doesn't give us length of the one used to in repairs. The electrician found that it carries a 2.5 A current when the same battery is connected to it. So it states that we're using the same battery, so we know there's one thing that doesn't change, which is voltage. So we know voltage doesn't change, and the length changed to a new length. We're gonna calculate the length, and we have two currents. So R2 equals 2.5 A. We're looking for L2, right? And we already know it's using the same battery, so the voltage doesn't change, such that we have a variable that doesn't change, so we're probably gonna make some comparison. So it's required. Okay, let's check the formula sheet. So voltage doesn't change. We can use this. This is useful, right? We can write down V equals R times. And then since V doesn't change, we can rewrite it as resistance 1 times current 1 equals. Now what do we have? We have current 1, we have current 2, so we can rewrite it to R1 equals 2.5A over 1.2A times R2. So now we have an equation here. Next, we're going to solve this 2R. And then we look back to formula sheet. We're going to pick one from these two, right? We don't talk about temperature here, so we're going to use this one. And write it down. R equals, we have a constant here. Times length over area. So since we're going to do the comparison, so the constant doesn't matter because we can cancel it out later on. So we substitute this equation to this one. We rewrite this one. We rewrite this one to constant times length 1 over area 1 equals 2.8 over 1.2 times. So now we can cancel out the constant. Then, also we can cancel out the area. Notice that here the A stands for area, not current. So the area is actually, we're talking about a wire here, right? So it looks like this. And this part is area. So we're cutting off, make it shorter so the area doesn't change, only the length change. So we cancel this to variable L. We can rewrite this to L1 equals. So now we already got the answer. So because we're looking for L2, we have L1. So the answer would be R2 equals 1.2 over 2.5 times 50 meter equals, let's see, 24 meter. Yeah, that's the answer. I mean, that's my answer. It's probably, I couldn't sure if it's 100% correct. That's why I'm showing you how I solve this question. So if I make mistakes, you can just point out where did it happen. Yeah, that's it. See you next question.